Now, the properties of the sum of a sequence can be found on this fancy PowerPoint here, which I will quickly show you. Alright, we have a sum, which we just found, that formula, n times a1 plus an divided by 2. Okay, the properties of this sum are that the sum can be defined, it can be a number, or not defined. Now, when we speak of a not defined, that is more or less an infinite sum that cannot be defined. If it is defined, which is, by the way, true for all finite sequences can be defined as such. If it's a finite sequence, then you can define it. It will have a number that we get, and it will be what we call convergent. It approaches a number. And we'll visualize this idea in a minute. If it is not defined, it means it's infinite, goes on forever, or it flips. It's changing between some kind of numbers, then it's divergence. The other thing that you need to know about the sum is that the common difference does not need to be known. Okay? These points of convergence and divergence are not in the book, so you might want to write them down. Okay. So let's visualize what in the world we mean by convergence and divergence. Okay. To say something is convergent means if I visualize it, this is my sum, this is my n. Okay. What's happening is that either my sequence approaches a number, whatever the sum is, or let's see. Or I'm looking at it as a piece of something. If I have something like this, some wave, I could also be convergent if I'm looking at a piece from, say, here to here. This is my sum. This is once again my n. In this situation, I'm looking at okay. I'm looking at a piece of a sequence. That's the situations we can have for that's the two situations we can have for what we call something that's convergent. Okay. If the sum is divergent, we have the following. Alright. I can't draw, so you'll have to bear with that. Okay, this is your sum, and this is your n. And you'll notice that the sum keeps going between places. It's not making up its mind. It's doing something, but I don't know what exactly. Okay, that's a situation divergent. We can call it oscillation if you'd like. Okay. The sequent can't make up its mind. Okay. Okay. It's trying to figure out where it's going, but I have no clue. The sum can't make up its mind. Okay, the sequence or the sum cannot make up its mind. The second situation we can have in divergence is something like this. In the second situation, we have the sequence doesn't stop. All right. Divergence applies to infinite sequences. Divergence applies to infinite sequences. Convergence applies to finite or finite sequences. Okay. The sequence doesn't stop. You can't have a sum if it doesn't stop going anywhere. Okay. That's the second situation. It's hopefully to clarify what I mean by divergence. Okay. And divergence and convergence. So now let us do an example of how to calculate some sums. So here's our example. Oops. There. So find the sum of those numbers. If I was to do that, I have this. The first thing I need to do is count the number of terms. And no, that's not a hashtag symbol, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n equals 10. The next thing I need to know is the first term and the last term, which is 10 and 40. And 40. Then, lastly, I can use the formula. Alright, so we use the formula, the sum of the first 10 terms is going to be n divided by 2, a sub 1 plus a sub n, which is going to equal 10 divided by 2, 4 plus 40. And so this ends up being 10 over 2 and 44. That kills that 22 times, so it's 220. Okay. All right. This is what we call a partial sum, meaning that I'm only finding a piece of the puzzle, the piece of an infinite of an infinite sequence. It's what we call a partial sum. I'll write that on the next page. A partial sum of an infinite sequence. So if I have an infinite sequence and I want to find the sums of it, it's a piece of it, it's a sum of an infinite. It's a piece of an infinite sequence. That's when we use what we call the partial sum, which the formula is exactly the same. So I don't even know why they tell you that. So for example, given my infinite sequence, the 125th, and the 125th partial sum. So to find the 125th partial sum, I need to know what the 125th term is, right? We need to find A125, right? So to get A125, we use the formula A sub n is equal to A sub 1 plus n minus 1 times d. The common difference here is 7. If you're just looking at it, 10 minus 3 is 7, 17 minus 10 is 7, 24 minus 17 is 7, 24 plus 7 is 31. So the common difference is 7. So we can use that to find the 125th term, which you technically don't even need. But hey, who's counting? Alright, there's another way around it, but we won't worry about that. If you don't... So, A sub 125 is equal to 3 plus 125 minus 1 is 124 multiplied by 7, which is our common difference. So 124 times 7, 868. 868 plus 3 is 871. From here, another partial sum equal 125 over 2, because n is 125, a sub 1, which is 3, plus a 125, which is 871. Okay. So it ends up being 874 divided by 2, 437 times 125, whatever the hell that is. So it's 54,625. So we get 50,625 for our sum. Alright. Simple enough. So I will leave you and we will come back and do some application problems.